It was such that depending upon the value of alpha, whether alpha was even or alpha was odd, depending upon this, we had seen that one part of the power series, because the general solution was something like C0 y1x plus C1 y2x. So we had seen that for alpha even or for alpha odd, one of them, either y1 or y2, they turned out to be polynomials and the other turned out to be infinite series. And that is why these polynomials were known as the Legendre's polynomial. Okay. Now it was observed that, like Legendre later on, I mean, once this alpha was required only as long as we were sort of, solving this equation. We can write this alpha as n also. So it's not going to make any difference, but the thing, it's just a matter of notation. So like in this case, we had said it's a Legendre's equation of order alpha. So if I talk of Legendre's equation of order n, then instead of alpha into alpha plus 1, I'll be having n into n plus 1. Okay. And that is why when we had seen the things, we had seen the solution, we had seen the polynomial, things were in terms of alpha. That's why giving different values to alpha, we could get whether it's going to be an even degree polynomial or an odd degree polynomial. Okay. Now, as I was saying, as it's mentioned in the book, it says that, what was done later on was to give a general expression for Legendre's polynomial. They somehow, he worked out and he said that we have to have a coefficient of p and x, something of the form, 2n factorial upon 2 to the power n into n factorial square. So somehow we have to make the coefficient, every coefficient of this form, and then we get a general expression for p and x, right? So instead of going directly into that, what happened was that Rodriguez, another person, he came up with a better and a simplified formula, to compute the Legendre's polynomial of order n. So that means we now have a general and a simple formula, simplified formula to compute p and x. So instead of solving the differential equation and then getting the polynomial, then putting on the values of alpha, what Rodriguez gave was that he has a general formula which is simplified, less messy than the one given by Legendre. Okay, so that is why it is this formula which is most frequently used to compute Legendre's polynomials. Okay. What we are going to do now is we are going to derive the Rodriguez formula as well as prove the fact that Rodriguez formula leads to the same expression of p and x that I gave yesterday. Okay, so these are the two things that we have to do. Okay, so how the Rodriguez formula works is basically Rodriguez formula says that Legendre's polynomial of order n is given by on to the n factorial into the nth derivative of x square minus 1 to the power n. Okay, this is called as the Rodriguez formula. Okay, that is why if you see, because of this expression here, even in the generalized expression as given by Legendre, we need the coefficients to be something of this form. Okay, so but then the point is, how do we arrive at this? I mean, of course, where did this come from, and how do we talk of the nth derivative here and n here, and how do we handle such terms? Okay, so to prove this Rodriguez formula for the Legendre's polynomial, what we do is we start with some u as x square minus 1 to the power n. Okay. Then by simple derivatives, u1, the first derivative is going to be 2nx x square minus 1 to the power n minus 1. Is that right? Which I can write as 2nx x square minus 1 to the power n upon x square minus 1. Am I right? See, mind you, plus minus 1 are still the singular points of your differential equation. So basically your un is nothing but 2nxu upon x square minus 1. Yeah, this is what your u1 is. Is that okay?
Yes, ma'am.
Yeah. Which means x square minus 1 u1 is 2nxu, or in other words, 1 minus x square u1 is minus 2nxu. Is this right? Or 1 minus x square u1 plus 2nxu is equal to 0. Is that right? I mean, I've not done anything great, just adjusted the terms. Is it okay? Now, in this equation, what I'll do is, I have u and u1 here, okay? Now we'll compute the n plus 1th derivative. Now see, they are product of two terms, okay? It's 1 minus x square u1, it's xu, right? So if I have a product of two terms and I have to compute the nth derivative of a product of two terms, we use a theorem which is called as the Lebanese theorem. This we have learned. Yaad hai? So what we'll do is we'll compute the nth derivative of this equation, okay, by using Lebanese theorem. Okay. Now, what does Leibniz theorem say? That if u and v are any two functions of x, then the nth derivative of their product is given by nth derivative of u into v plus nc1 un minus 1 v1 plus nc2 un minus 2 v2, and so on and so forth. The last term is uvn. This is what Leibniz theorem says. Okay, but then this was to compute the nth derivative. And if you remember, the choice of u and v, see, it is for un, we are writing, for u, we are writing the nth derivative directly, but it is this v in which we are computing the derivatives. So when we have a product of two terms and we want to apply Leibniz theorem, we remember that the choice of v should be such that its derivatives vanish after a certain stage. That's why we take polynomials as v and the other function as u, if you remember it correctly, right? So here, this is the formula for the nth derivative. And what are we going to do? We are going to compute the n plus 1th derivative. So instead of n, we'll just be having n plus 1. That is the only change here, right? But then obviously, in the first expression, we are going to take u1 as our u and 1 minus x square as our v. Similarly here, my small u will be my u and my x will be v. Is this clear?
Yes, ma'am.
So if you apply Leibniz theorem, then it's going to be 1 minus x square. This is my v. What is the first term? u n v, right? So that means nth derivative of u. But here it's going to be n plus 1th derivative of u1, right? So u1 means what? The first derivative of u. So then n plus 1th derivative of u1 would actually mean the n plus 2th derivative of u, right? This is my first term. Then plus, now it was an n plus 1th derivative. So it's going to be, okay, n plus 1 c1 into the first derivative of v, which is nothing but minus 2x, into, now it will be un plus 1. Okay, one derivative less than that of u, right? Plus n plus 1 c2 into the second derivative of v into the nth derivative of u. These will be the three terms After that, the derivatives will vanish. So that means from the first term, we are going to get just these three terms, this, and this. Is this clear? Hmm?
Yes, ma'am.
Plus. Now we go to the next term, plus, what was that? 2nux. So that means it will be 2nx. Now it's n plus 1th derivative of the whole expression. And we already had a u here. So we are going to, this was the term 2nxu. So it's going to be n plus 1th derivative of u only. So this will be the first term. Then plus 2n plus 1 c1 into un, because the derivative of x is 1. That's it. There will be no other term equal to 0. Now you can simplify it. So we are going to get 1 minus x square un plus 2 minus, now n plus 1 c1 is n plus 1 only. So it will be minus 2 n plus 1 x un plus 1. N plus 1 c2 will be what? N plus 1 into n upon 2 factorial. Okay. And then a minus 2un, right? Plus 2nx un plus 1 plus 2n n plus 1 un equal to 0. Now, can you just quickly simplify and give what you get? The first term will be 1 minus x square un plus 2. Now, just combine the coefficients of un plus 1 and un quickly, and let's see what we get. Can you do it?
minus 2 un minus 2 x un plus 1.
Yeah, minus 2x un plus 1. That's right. And what will be the coefficient of un? Hmm?
n into n plus 1 un.
Plus n into n plus 1 un equal to 0. Perfect. This is what you are getting. I mean, all of you should be getting this. Okay. Now, if I want, can I not write it as 1 minus x square? What was the first term? Un plus 2, which means the second derivative of un, n plus 2, right? Then minus 2x n plus 1. That means what? The first derivative of un plus n into n plus 1 y equal to 0. Sorry, y, not y. I'm sorry. This is un equal to 0. I can write it like this? Yes or no?
Yes, ma'am.
Now compare it with your Legendre's equation. Sorry. Alpha into alpha plus 1y equal to 0. This is your Legendre's equation? if I compare this, this equation with this equation, isn't it your Legendre's equation? What is the difference? Y un and alpha n. यही तो फर्क आया. That means we can say that y equal to un is a solution of Legendre's equation of order n. Alpha की जगह n हो गया ना. This was a Legendre's equation of order alpha. But here we have alpha equal to n, so that means we have a Legendre's equation of order n. So if y equal to un is a solution of Legendre's equation, and we have already proved that Legendre's equation has a power series solution, so definitely this un is also a power series solution. This y is nothing but a power series. Or in other words, if I say that let Pnx be the power series solution of this, of Legendre's equation of order n, then my Pnx is actually nothing but some constant into un, because I'm writing the general solution now. Y equal to un, it has turned out to be a solution. But what will be the general solution? Some constant into un, okay? Because I don't know what kind of, maybe un itself has two arbitrary constants, but to be doubly sure, I'm taking another constant with that, and I'm writing my Pnx, which is the power series solution in terms of a and un. Is this clear? Okay. Now, see, what was your u? Your u was x square minus 1 to the power n. So what do we mean by un? Un means the nth derivative of x square minus 1 to the power n. So basically, your Pnx is nothing but a into the nth derivative of x square minus 1 to the power n. Is this clear? Which means your Pnx is nothing but a into the nth derivative of x minus 1 into x plus 1 to the power n. Is it right or wrong? Is it okay or not? Okay, just move on. Then we'll have questions in the end in case you have any doubts, okay? Now, the value of this a can be obtained only if I have some initial conditions, okay? So to impose those initial conditions, I say, let Pn at 1 be 1. That means what? That means I am assuming that the value of Pn when x is 1 is 1, okay? Now, Pn at 1 equal to 1 means 1 is equal to a into the nth derivative of this term, x minus 1 to the power n, x plus 1 to the power n. This derivative evaluated when? When x is 1. Is it okay? Right? So that means what? That means we have to evaluate, we have to see. See this, this is not so direct in the sense that I have a product of two terms which itself are, exponents in the sense that we have power as n, and we are not talking of just the first derivative. We are talking of the nth derivative here. Okay, so again, to compute the nth derivatives, we have to make use of the Lebanese theorem again. Okay, so basically, since the space is left, I am moving on. So basically here, this means that your left-hand side is still 1, which is equal to a into. So now it's like I can take any term as u and any term as v. So I'll take x minus 1 to the power n as u. So what is the first term? The nth derivative of x minus 1 to the power n. This is what the first term is, un into v, which is x plus 1 to the power n, right? Plus nc1 into the n minus 1th derivative of this term into n x plus 1 to the power n minus 1. Right. Similarly, what will be the second next term? nc2, the n minus 2th derivative of this term into the second derivative of v, which is n minus 1, x plus 1 to the power n minus 2, and so on, so forth. The last term will be, it will be u as it is, but the nth derivative of v, which is nothing but x plus 1 to the power n. Okay. Is this okay or not?
Yes, ma'am.
Right. Now see, when we talk of the nth derivative of x minus 1 to the power n, what will that be? Any guesses? What is the derivative of x to the power? What is the nth derivative of x to the power n? Okay. What is the second derivative of x square?
2.
2. What is the third derivative of x cube?
6.
What is 6 in terms of 3? Hmm?
3 into 2.
So what is 6 in terms of 3? What is 3 into 2 into 1?
3
Ma'am,
factorial.
What is the fourth derivative of x to the power 4?
24.
What is that?
4
Factorial. So what is the nth derivative of x to the power n?
n factorial. N factorial into x raised to the power n minus p, where p ranges from 1 to n.
Q? I'm just saying nth derivative of x to the power n.
n
P कहाँ से आ गया?
Ma'am, x n factorial.
N factorial. So what will be the nth derivative of x minus 1 to the power n?
It will also be n factorial.
And G? फिर से बोलो.
Ma'am, n factorial. N factorial.
It will be n factorial. Okay. So that means it is n factorial into x plus 1 to the power n. Right? Plus, what is nc1? N into, now it is 1 minus n minus 1th derivative of x minus 1 to the power n. Now, what is the third derivative of x to the power 4? Hmm?
4 factorial into x. 4 factorial x.
Into x, right? So what will be the n minus 1th derivative of x to the power n?
N minus 1 factorial into x.
Not n minus 1 factorial.
Please repeat the question.
I am saying what will be the n minus 1th derivative of x to the power n?
Ma'am, n factorial into x.
Very good. So what will be the n minus 1th derivative of x minus 1 to the power n?
n factorial into x minus 1.
Okay.
Ma'am,
Bolo. I'm writing the next terms. That means what? That means starting from this term onwards, all other terms will have x minus 1. See, why I'm writing this is because I have to compute this derivative when x is 1. That means the only term, see, if when x is 1, this term will be 0. Because I have x minus 1 here. The next term will be 0. Again, the last term, this is x minus 1 to the power n, right? So that means what? That means except this first term, I'll have terms that will contain x minus 1. And what will happen to them when I substitute x equal to 1? They'll all be 0. That means the only thing I'm getting, the only non-zero term when I substitute x equal to 1 is the first term. And in this also, if I put x equal to 1, what does this term become? 2. So that means basically when I use the fact that Pn at 1 is 1, I am getting 1 is equal to a n factorial into 2 to the power n. The all other terms will be 0. Is this okay or not?
Yes, ma'am.
Yes,
Right.
ma'am.
So that this equation itself gives me the fact that my a is nothing but 1 upon 2 to the power n into n factorial. Right. So in what was your p and x? Your p and x was a un. That means it is now, what is a? 1 upon 2 to the power n, n factorial. And un means what? The nth derivative of x square minus 1 to the power n. And this is what I said is your Rodriguez formula. Is it okay or not? Now, how to use it? I'll write it again because see, this is a very simplified and very easy to remember kind of a formula. Your Pnx is 1 upon 2 to the power n, n factorial into the nth derivative of x square minus 1 to the power n. Okay. Now, I want to find the polynomial of degree 0. That means I put Pn equal to 0, so I am getting P0x. So what happens when n is 0? क्या हो गया सब जगह? What is 2 to the power 0? 1. 0 factorial 1. That's it. No need to talk of here. So you're getting your P0x as 1. And that was the first polynomial that you got by putting alpha equal to 0. Similarly, when you put n equal to 1, that means I'm talking of Legendre's polynomial of degree 1 or of order 1. What will that be? 1 upon 2. Now your n is 1. D by dx of x square minus 1 because your n is 1. So what is that?
X.
X. So this is your Legendre's polynomial of degree 1. Similarly, when you put n equal to 2, you're going to get P2x. What will that be? 1 upon 2 square 2 factorial into the second derivative of x square minus 1 square. Because you have to substitute n everywhere. Okay, can you just quickly simplify what you get? What do you get? Compute till P5, all the polynomials, P2, P3, P4, P5. कितना आ रहा है P2? I know it takes time, but then you are getting your polynomials.
Ma'am, x by 2.
No, P2 is a second degree polynomial. Second derivative.
मैम 3x स्क्वायर माइनस 1 अपॉन में 2 आ रहा है.
हाँ, कितना बोलो फिर से? 3x square minus
3x स्क्वायर
हाँ. So which is
upon
basically
में
1 by 2, 3x square minus 1. It's a second degree polynomial. Right? Similarly, P3. So I'm leaving it to you. Compute P3, which will be nothing but 1 upon 2 cube 3 factorial into the third derivative of x square minus 1 cube. Right? Similarly, I'm leaving it to you. P4, P5 and P6. ज़्यादा हो जाएगा, but then do. Because we need to plot them in the lab class, okay? So just compute them and then you will see. See, that means, see, one thing is very clear from here. P0x is just a constant. That means a line, straight line. Similarly, P1x is also a straight line, but passing through the origin, x. P2x is a second degree polynomial, so it has a curve. P3x is a cubic polynomial. P4 will be a fourth degree polynomial. So that means subsequently they'll all be like P2x will be a parabola because it's of this form, right? Similarly, P3x will be some other curve. P4x will be some other curve. So basically what you are going to get is again curves, with increase in degrees as you increase your n here, okay? Now, as I said in the beginning of the class, the question mark is, okay, fine. We have obtained the Rodriguez formula and we have seen that it's much more easier to compute the polynomials using the Rodriguez formula rather than using the Legendre's directly. The question mark is, are the two equal? I mean, see, we have two expressions here now. One way I'm writing my P and X as this, 1 upon 2 to the power n factorial into the nth derivative of x square minus 1 to the power n. And initially we were writing our n as n varying from 0 to capital N into, k. K varying from 0 to capital N minus 1 to the power k 2n minus 2k factorial upon 2 to the power n into k factorial into n minus k factorial into n minus 2k factorial x to the power n minus 2k. As you can see clearly, it's much more easier to use this, where we know capital N was nothing but the integral part of n by 2. Okay. If n is even, then we have no problem. But if n is odd, then the integral part of that decimal is your capital N. That means that's where you have to take the summations. Okay. So basically, this summation has to end up at either n by 2 or n minus 1 by 2, depending upon whether your n is odd or even, right? So it's very obvious from the two. It's much more easier to use this formula than this. But the question mark is, are the two equal? And the answer is yes. We can prove that also, that the two formulae that we have derived, that we have seen, they are actually equal. They're not different from each other. To prove that, again, we'll use terms of binomial expansions and Leibniz theorem also. See, what is x squared minus 1 to the power n? If you use the binomial expansions, then it's going to be nc0 x squared to the power n. Yahi hota hai na? It's like a plus b to the power n, right? So plus nc1 x squared to the power n minus 1 into minus 1 plus nc2 x squared to the power n minus 2 into minus 1 square and so on and so forth. The last term is going to be NCN minus 1 to the power n. Is that right? In between, can you write a general term also? Isn't it going to be something like NCR x square to the power n minus r minus 1 to the power r? ऐसी होगी ना जनरल टर्म बीच में कहीं?
Yes, ma'am.
That means I can write my x square minus 1 to the power n as summation of terms like NCR x square to the power n minus r minus 1 to the power r, where r varies from 0 to n. लिख सकते हैं ना?
Yes, ma'am.
I've just given a general expression for this. Now, which is actually nothing but minus 1 to the power r as it is. What is NCR? N factorial upon r factorial into n minus r factorial into x to the power 2n minus 2r, r varying from 0 to n. Is that right? Yes or no? That's why I
Yes, ma'am.
said you have to write simultaneously. तभी समझ में आएगा, है ना? That means if I have to take the nth derivative of x square minus 1 to the power n, then that will be nothing but the nth derivative of this summation, जो अभी हमने लिखा, r from 0 to n. I'll write it again. N factorial upon r factorial into n minus r factorial x to the power 2n minus 2r. Right? Now see, this term is constant, this whole term. The only term containing x is this. So basically this will be nothing but summation r from 0 to n minus 1 to the power r n factorial upon r factorial into n minus r factorial into the nth derivative of x to the power 2n minus 2r. Right or wrong? ठीक है ना? Which is nothing but summation r from 0 to n minus 1 to the power r n factorial n minus r factorial into the nth derivative of x to the power 2 into n minus r. ठीक है? Fine. Now see, according to Rodriguez, what was your Pnx? It was 1 upon 2 to the power n factorial into the nth derivative of x square minus 1 to the power n, which is nothing but 1 upon 2 to the power n factorial into. Now, instead of this term, can I not write this whole summation? Because this is the nth derivative of x square minus 1 to the power n. So that means this is nothing but this into summation minus 1 to the power r n factorial n minus r factorial into the nth derivative of x to the power 2 into 1 minus r, where r varies from 0 to n. Okay? Is it okay or not?
Yes, ma'am.
अब थोड़ा सा rough work. In the sense, just see. We'll see how I'll just keep this as it is for me because now I want to write the expression for this term. Okay? How is this behaving? Okay, so to do this or to write this, we need to understand the behavior of, see, we know the behavior of nth derivative of x to the power n, right? We know, I mean, the nth derivative of x to the power n is n factorial. N minus 1th will be n factorial into x. And previous, we can go backward also, we can go forward also. But we need to study the behavior because of the presence of r here. We need to study the behavior of the nth derivative of x to the power r. How does it behave? Okay, now see, when n is 1, that means first derivative of x to the power r. What is that? R x to the power r minus 1. Okay. Now, because I have factorials here, so I would like to express this as a factorial again. Okay. That means, see, what do I have? R. Now, r is actually nothing but r factorial upon r minus 1 factorial. Is it right or not?
Yes, ma'am.
Into x to the power r minus 1. So basically, this means that the first derivative of x to the power r is actually nothing but r factorial upon r minus 1 factorial x to the power r minus 1. Now let's see what happens to the second derivative. Second derivative of x to the power r. What should it be? r minus 1, यही होगा ना, into x to the power r minus 2. यही होगा ना, second derivative,
Yes, ma'am.
which I can write as r factorial upon r minus 2 factorial into x to the power r minus 2. Is it okay or not?
Yes, ma'am.
Fine. That means in general, the kth derivative of x to the power r. Now I need to compute. I can directly write it as r factorial upon r minus k factorial x to the power r minus k. And in general, what will be the nth derivative of x to the power r? R factorial upon r minus n factorial into x to the power r minus n. Is it okay or not?
Yes, ma'am.
Now, but we don't want the nth derivative of x to the power r. We want the nth derivative of x to the power 2n minus 2r. So, using this, what will be the nth derivative of x to the power 2n minus 2r? Instead of r, just in this expression, what we derived just now, instead of r, just write 2n minus 2r and you have your answer. क्या होगा बताओ तो? What will be the numerator?
2n minus 2r factorial.
2n minus 2r factorial. Now, what should be the denominator? it should be r minus n. But instead of r, what do we have? 2n minus 2r. So it will be 2n minus 2r minus n factorial into, what is the next term? X to the power r minus n. But instead of r, what do we have? 2n minus 2r. So it will be x to the power 2n minus 2r minus n. Right? So what do you get? This is nothing but 2n minus 2r factorial upon, what does it become? 2n minus n. Matlab n minus 2r factorial into x to the power n minus 2r. This is what we get.
Yes, ma'am.
Fine. Now substitute this in your Pnx, the one that we had here, this summation. So we'll retain this term as it is, but instead of this term, again, see, we wanted things in terms of factorials. That is why we did all this exercise. Okay. So that means if I substitute there, my Pnx is now 1 upon 2 to the power n factorial as it is, summation, right? What was the previous term? Minus 1 to the power r into n factorial upon r factorial into n minus r factorial. This was there. Now, instead of the nth derivative, now I'll have terms like 2n minus 2r factorial upon n minus 2r factorial into x to the power n minus 2r. Okay, which is actually nothing. Abhi, I am not writing anything here because we need to study. See, this r has to vary from 0 to where? That depends, right? So now I'm just trying to simplify this 1 upon 2 to the power n factorial summation r varying from 0, definitely. Now, what are the terms going to be? Minus 1 to the power r. Now, this is can we have okay, yeah. Look at this n factorial and then this n factorial can get cancelled and we'll just have 1 upon 2 to the power n summation minus 1 to the power r 2n minus 2r factorial upon r factorial n minus r factorial into n minus 2r factorial x to the power n minus 2r. Now see, how far can r go? From 0 to which place? I want this term to be always, say, positive. Minimum क्या हो सकता है? 0. Okay, so I want this to be non-negative, basically. So for that, I need not bother because my r is starting from 0, definitely. So when r is 0, this is x to the power n, right? When r is 1, it is x to the power n minus 2. But when r is 2 and so on and so forth. But how far can r go? You have a 2r here.
n by 2.
N by 2. When? But n by 2 is an integer only when what happens?
N is even.
When n is even. So that means basically when n is even, it should end up at n by 2. But what if it is odd? Where should it end up with? उससे पहले वाला integer? उससे
Yes,
पहले
ma'am.
वाला even integer? अगर n odd है तो कहाँ खत्म होना चाहिए उसको, जो उससे एकदम पहले वाला even integer है. So what is that? n minus 1 by 2. Is this okay or not? Because उसके बाद तो फिर ये negative होना शुरू हो जाएगा, which we don't want. See, अगर 2r n से बढ़ गया, if this value is more than n, then I'll have x to the power which is negative, which we don't want, because we are talking of positive, we are talking of a power series here. So I cannot have a series in which I have 1 by x, 1 by x square, and so on and so forth. So that means we can only have terms as long as my power of x is positive. Okay, and that will happen only when r terminates either at n by 2 or at n minus 1 by 2, depending upon whether my n is even or odd. And that is why we say that this r varies from 0 to capital N, where capital N is nothing but the integral part of n by 2. So if n is even, it itself is the integer. If n is odd, then the even integer prior to that odd is your capital N. So this is where this summation ends. And this is exactly similar to what your Legendre gave. So you can take this 2 to the power n also inside the summation, and you have the same expression. It's just that instead of k, we are writing r. That is the only thing. And that was deliberate so that, you know, it's more clear to you. यही आया हमारे पास 2n minus 2r factorial upon. Now I have taken 2 to the power n also inside the summation. So what do I have? R factorial into n minus r factorial into n minus 2r factorial x to the power n minus 2r, where r varies from 0 to either n by 2 or n minus 1 by 2, depending upon whether my n is even or odd. So you have both the formulas as same. Okay. Is this clear?